Hello, my name is Jamil Spain, developer advocate with IBM Cloud. And my topic for today is message queuing. Now, as a technologist, when I first started out developing applications, there was an expectation that in my code that applications would process everything immediately. And even when I first started dealing with REST APIs, that's really the expectation that I make a front end makes a REST call to a back end through a REST API call, that you're expecting a response to come back. Some type of response code must go back to let me know 404 was not good, 200 it was good. But again, there's that expectation that things happen instantly and I get instant confirmation that something is happening. And often I wrote a lot of code to accommodate situations where that communication could not happen or did not function properly there. But today's topic kind of branches out through that. Let's break down what the term message queuing actually means here. So overall, from a 30,000 foot view, it's definitely a architecture technique that allows you to break applications apart. Apps apart with what we like to call asynchronous communication. I'll abbreviate that there. So asynchronous communication. So I want my particular applications or particular subsets to still function and not worry about the other parts there. Versus the other part where all my code was in one stack and only in a monolithic application, or when I build an application where all the functionality exists, that one set of functions or one set of code of my application, I'm just always handling a transaction off to another set of code, but there is that expectation that things follow through and process right then. There's no way to really kind of delay things to happen later. And this is what message queuing is all about. But let's break down the first part here. First, let's deal with the word message. And as it denotes that it is really something that a piece of information that wants to get processed from one system to another. An application, we'll just say subsystem from here. That's what I'll kind of denote it by with that particular piece. So you have data that needs to get transmitted. Now this could be actual data payloads, actual files. It could be metadata that references that something should happen on the other end. So many different types of data formats can be there. All right, and then we have the word queue, which queue in the most simplest form refers to kind of a line of things that are processed sequentially. So when you think of a message queue, think of the messages of coming into a queue as a way that kind of holds the messages in the order they are received and delivers them to the actual party. So one way to think about this, I know this kind of explain message, explain queuing, explain the overall, but think about a tool that everyone uses every day. Email. Email is an excellent example of asynchronous communication and how that works. I can theoretically, or not theoretically, actually in reality, in real life, I send a message out, but I can wait for a response later. It goes into an inbox. Think of that inbox, your email inbox, as a queue of messages that are held there. And at some point, the person who's going to receive it has the opportunity to look at it whenever they want. If they take a longer time, there's a larger list, that has accumulated of messages that you have to read, which is usually the case when I go through some of my email boxes. Or for ones that I check constantly, like say for instance your work email, you're always constantly going through the list, so you're there waiting to kind of reply back. But excellent example of asynchronous. I can really fill out an email, compose it, send it off. I'm not worried about whether you received it or when you answer it, but I can move on to something else. All right, so perfect example of asynchronous, and we'll carry that example through as well to some of the use cases here. So we talked through those. Let's talk about the type of messages that occur. So we've mentioned queue, which is a line of of messages. So if I were to draw this out in this perspective here, let's do it this way. Let's take this green as the queue. And then let's say that each one of these is going to be an actual message. And so at some point you're going to have they're going to send the kind of the message here. And then at the other end, somebody's going to open it up. Got my little envelope there. All right, a little artwork here. So the person that's putting the message on is going to be what's known as the producer. And then the person consuming the message is the consumer. So these are often the two profiles or roles that you can take. And of course, you can be the producer one time and be the consumer on another example. So this one pattern here that you're looking at is more like a point-to-point. I am sending it from one application to the other. All right. It could be let's say I have a web form and you're filling out. And as you complete the web form, I take the metadata from that form, JSON object. I can put that on a queue to be processed later, to be inserted into a database, to be inserted to another system for marketing automation, whatever it may be, the use case. The point is that I need messages to guarantee delivery to get there and not be dependent upon you submit the form, I send it back to that other system and get a response back. I can keep ingesting particular messages, form submittals, and keep loading those in to go from there. So when you have these kind of use cases, these are excellent things that should read out that, hey, instead of me just doing direct HTTP connection, let me think of a message queuing pattern that I can facilitate to go here. So we'll call this point-to-point. The next one is something like a publish subscribe, also abbreviated as pub sub that you will hear. And this works from the capability that I have a producer. Let's go back to the green. I'll do another queue and we'll do more messages that come in. So on the pub sub model, I'm going to have multiple parties or applications that are interested in getting this message as it comes through. All right, so publish, subscribe. So these consumers are listening for this particular, I'll call it a channel, or interested in this particular thread of messages that may come across. So it could be that new customer signs up. You may want to send something to, or a new order, e-commerce order comes in. You may want to send something to accounting for an invoice to go out. You may want to send something to the shipping or notifications for stock or, any multiple things that you want to kind of get through. That could be something you can shoot out to kind of go. And the last one I'll work through is what we like to call request reply, reply requests. It's done from the standard that you have a producer that's going to send out a message. All right. Let me redraw this again really fast here. I got messages that I'm going to put in. Okay. And so this could be one way. They could have one channel. All right, so they could be one way where they want to go out. Someone could consume it. I could put a request out. Someone gets it, does some processing, but the response to that they want to do, I'm going to also be listening on another queue for the response to that. So that could be now that all of a sudden, where they're reading this request that comes through, they then could put the resulting workload or whatever computation that they're doing, whatever algorithm that must be done. Say, for instance, maybe some of those patterns where you want to put your information in and look at all the offers that are out there. It could be an actual search to go out and get all this information, compile that back to maybe a list of object. That information comes back, and then I'm listening. The producer's also listening to another queue to say, oh, the response is ready. And then it takes that information and then presents it. So you have point to point. All right, this is a pub sub, and then more of a request and reply. All right, so different type of messaging patterns that can occur. And again, I love to kind of think through things from a backwards perspective. It's really about, as a technologist and then a solution architect, sometimes you want to put your hat on where you say, what is my intent? What do I need to happen? And that really drives what particular piece of technology can drive that particular component here. All right, so 3 patterns. We identify message queuing. Let's wrap it up with the benefits naturally of why you want to facilitate or go through the effort to orchestrate something like this. And I like to bring this down to 2 major particular pieces here. The first, decoupling. All right, it looks like an M, but it's really an I and an N. All right, trust me there. All right, so decoupling here. So what this allows me to do, we mentioned the first part about breaking applications apart. It allows me now to have separate items that can occur. So I can, in going along what we like to call the microservice pattern, responsibility pattern, I can dedicate one particular piece of code application to just be responsible for that one piece of work. All right. And if I was in a monolithically kind of code base, I would have to progress things all at one time. If I wanted to just work on my payments module, I would also have to test everything to make sure how that affects other parts here. Well, in this particular piece, let's say I just wanted the web front end to be the web front end. I don't want you to handle a lot of the processing and doing all the database connections from there. I'll let other systems do that part, or they can be very well at just connecting to my database, connecting to my services and my systems of record, anything from that. So decoupling allows you to really separate things up where apps can just be apps, just perform their particular job here as well. And naturally, that will enforce scalability in your application because now you have apps that are decoupled. You have teams that can work on applications. I can think about my application much simpler. I may have one component that I want to work on at a time while the others are guaranteed to function as is. And also, it allows me to add more resources to certain parts. As we mentioned in the other use case earlier, where I have a web form that wants to maybe handle a lot of high traffic of submitting, or my front end may have a lot, but I may want to wait before I process a lot of that on the back end and not have that immediate. I may want to put it through more checks, maybe more detection, maybe more actual code to detect for any of these things. The use cases are really numerous here. I'm trying to simplify it down to something simple that we can digest here. But this allows me to have some things that can scale out to meet demand without having to scale the whole application up. So I immediately get that piece here. And so from a perspective of processing of data, this is great for me. And I can also evolve other sections of my code to work better, scale faster. I want to swap in out different components, all right? Even in my decoupling, whereas before monolithically, I probably am writing everything in one language because it's all one single code base. Decoupling gives me the ability to maybe lean on other languages for certain expertise. I may have my front end in a Java, but my back end may be in a Node.js or any other language, Python. I can take advantage of many different other benefits that other languages can offer because, again, it's all about the single responsibility of work that they must achieve here. So, to summarize it all, message queuing, it's definitely for the new developer. It is something to consider from an architectural perspective of what you want to achieve. For our existing developers, I started out as a LAMP and a Ming developer myself. Started out from monolithically, moved into HTTP communication between services. And this is definitely a technique that I have embraced in my hybrid architecture to say there are some circumstances when these patterns resonate with me. I'm like, yes, that would fit perfect to work. Definitely, if you're getting in the cloud native, being that we have things that are decoupled or at the part that you need many different pieces to function together to connect them together, message queuing is a great segue to get you immediately there in the cloud native world. So definitely a great technique to try here. Hope this video was useful. I can't wait to hear how you're going to implement message queuing in your architecture. Thank you for your time.
If you have questions, please drop us a line below. And if you want to see more videos like this in the future, please like and subscribe.